This is AP Calculus AB. We are on worksheet 2-1 for basic power derivatives. All right, we have a lot of different rules. Let's go through, starting with number 1. So I'm noticing that I'm definitely in powerhouse. I mean, all of these are essentially a powerhouse rule, which means the 2 is going to come down in front, making this let's zoom in here, a 2x, and then this power here goes down 1, so instead of 2, it's 1, and whenever I have a power of 1, I don't write the 1, so just 2x. So maybe I'll say 2x to the power of 1, and then I'll write 2x finally. You don't have to do that. I'm just making my static answer key in the same video. And number 2, again, it's powerhouse, so 2 is going to come down in front. 2 times a negative 2 is a negative 4, so this is a negative 4, and then x to the power of 1, but again, I'm going to stop writing that. It's just negative 4x, so negative 4x, and let me box all of my final solutions in this video. I'm going to try not to mix or miss a single one. All right, this is a different way of writing this, and you can see the entire right column does it this way, but if my function is 3x squared, find f prime of x, which means take the derivative of this function. So again, the 2 is going to multiply down in front. 3 times 2 is 6, so we'll say f prime of x is equal to 6x, and now this 2 is going to go down a power to the power of 1, and we don't write the 1, so we just say 6x. So I'm going to go ahead and box my final answer. I know that these seem kind of easy to begin with. They do get a lot harder, especially on the backside. All right, so now what's happening here? So again, the 2 is going to be multiplied down in front, and some of you can instantly say, okay, the 2 and the 2 will cross cancel, but if you can't see that, let me go nice and slow. I had an original negative 1/2 out in front. By the way, it doesn't matter if the negative is on the top, if it's on the bottom, or if it's out in front. I mean, to be consistent, I can put it out in front. It doesn't really matter. If I take this 2 and I multiply it down in front, I can say that there's a 2 here, technically 2 over 1, that's being multiplied by this negative 1/2. And then I have x that goes down a power from 2 all the way down to 1, and you don't write the 1. So this is the final answer, and you can see here that the 2's are going to cross cancel, leaving behind just the negative. So this negative is left behind, and the final answer here is a negative x. So what I'm expecting from all of my students in the future is to be able to see that the 2 and 2 will cross cancel because the 2 goes on top and they cross cancel, leaving behind the negative all in one step. Try to do that all in your head from here on out. I know it might be hard. You can show your work, but try to move towards that. That's your goal, right? So again, I see a 2 that's going to be multiplied down in front, and you can see, I'm gonna draw the 2 here. This 2 and this 2 will cross cancel. Let me show all my work though, because this is the static answer key that I'm making. I will have that 3/2. By the way, you can pull out that 3/2 right there. And then I have this x. The 2 is going to be pulled down in front, so let me write that 2 here. And then I have x to the power of, it goes down from 2 into 1, and I don't write that 1. So there's my final answer, and you can see, yes, these 2's do indeed cross cancel, and our final answer here is just the 3x, which I will then box. But again, you can see that all in one step, that the 2 comes down and cross cancel in your head, leaving behind the 3x. All right, number 6, we have f prime of x, therefore will be equal to, again, the 2 comes down in front, so it's going to be 2 times this a times the x, and it goes down to a power of 1, which we don't write, so it's just 2ax. It kind of is tricky, like when do you have a variable? We're always assuming that we're taking the derivative with respect to x, which is why the a still stays there and the x went down a power. All right, moving on to number 7. So we finally have a non-x squared. We have an x to the power of 3. X power of 3 comes down in front, and you can say that's 3. X to the power of, okay, this goes down a power. It goes down from 3 to 2, and we're done. In number 8, again, we're going to say that the 3 comes down in front. 3 times a negative 2 is a negative 6. So we can say a negative 6. X to the power of, and it goes down a power from 3 to 2. For my final answer, negative 6x squared. And then coming over here to find f prime of x, that is going to be equal to 3 comes down, multiplies by 5. 3 times 5 is 15. X to the power of, it goes down to the power of 2 from 3. And I box it. All right, number 10. So again, hopefully you can see this shortcut, right? The 3 is going to be multiplied right in front. That 3 and that 3 are going to cross cancel, leave behind a negative 4. And I'm gonna do this the long way. So I'm gonna say I had a negative 4/3 here. It doesn't matter if the negative's on the top or the bottom. I'm just gonna leave it on the top for now. And then I'm gonna be multiplying by a 3 as well, technically a 3 over 1. And I have an x that went down from 3 to 2, so power of 2. And again, the 3's will cross cancel, leaving behind a negative 4x squared. But hopefully you're starting to be able to get that on your own all in one step. In number 11, again, you should be doing this all in one step. The 3 is going to come down in front right here. The 3 and 3 will cross cancel, leaving behind just the 8x to the power of 2. So I can do that all in my head, but I want to show my work for this worksheet just in case students get confused. So this is going to be, I have my 8/3. I'm going to be multiplying by the 3 out in front, technically a 3 over 1. And this is going to be x to the power of, it goes down to the power of 2. And then from there, 3's are cross canceled. And this is going to be 8x squared. Final answer, box it. Moving on to number 12. So again, you can see, yes, the 3 is going to come right here, and then that 3 and that 3 are going to cross cancel, leaving behind a kx squared. You can get kx squared all in one step. So I'm going to show all of my work in this worksheet, though. I'm going to say that this is going to be, I have this k over 3. It's going to be x to the power of 2 because I went down from 3 to 2. And this 3, where to go? I'm going to put it out in front, so I'm going to put it right here. 3 over 1 is being multiplied by this, and again, 3's and 3's cross cancel, and this becomes kx squared. Final answer, box it. All right, moving on to number 13. All right, we have a power of 4 this time. Power of 4 comes down in front, so I have a 4x to the power of. It goes down from 4 to 3, and done. In number 14, again, 4 gets multiplied down. 4 times a negative 3 is a negative 12. This is going to be x to the power of 3. It went down from a power of 4 down to a power of 3. In number 15, to find f prime of x, that's going to be equal to, okay, 4 gets multiplied down in front. 4 times 5 is 20. X to the power of, this goes down from 4 down to a 3. And final answer, so box it. And number 16, this is the constant rule. If you've forgotten it, it is up here at the top. Anytime that you take the derivative of a constant, k for constant, because we can spell really well in math, you get to 0. So anytime that you have derivative of a constant, this is just 0. And by the way, this is a non-variable. I know that over here we'll eventually have, I don't do a variable. I thought I was going to do a variable later on. I changed my mind, I guess. So 0 is the final answer. Box it. And again, this is the derivative of a constant, therefore the answer is 0. And yet again, it's the derivative of constant, so to find f prime of x, that's going to be equal to 0, and we'll box it. Kind of silly. All right, last 3 problems on this side, and then it becomes truly hard. Negative 1 is multiplied down in front, and negative 1 times a negative 4 is a positive 4. And then x goes down to a power of negative 2 because I'm going down from negative 1 to another negative 2. And this is a correct answer. You can box this. This is fine. However, on the AP test, this type of question is almost always going to be a multiple choice question, which means you should be comfortable with another form. You can say this is also equal to 4 over x squared. Do you need to do this form in your homework? No, but you need to be comfortable going from here to here. If you cannot see that the x squared moves and the 4 stays up here, you need to practice this. If you're very comfortable, like 5 out of 5, getting from here to here, you do not need to do that on the homework. I'm doing it. Oh, that was a terrible box. I'm doing it because you guys need to see that those are also the same form. And I'll write here, same answer, different form. All right, same thing down here. The negative 1 is going to be multiplied by a positive 2, which is a negative 2. And then the x is going to have a power of, well, negative 1 goes down to a negative 2. So this is the answer. I'm going to show you how to rewrite this. This is the same thing as having the negative 2 on the top over an x to the power of positive 2 on the bottom. Both of these are valid answers that you should be looking for on a multiple choice test. And again, let's do another one. So I have a negative 1 being multiplied down. A negative 1 times a is a negative a. So f prime of x in this case is a negative a. X to the power of goes down to negative 2. So this is an answer. I'll box it. But it is also the same thing as a negative a. Oh, that was a terrible negative a. Negative a all over x squared. Both of those are valid answers. All right, front side done. Moving on to the back side. We should be getting a little bit harder now. So negative 2 multiplied by 2 is a negative 4. Negative 4x to the power of, well, negative 2 goes down to a negative 3, and we're done. Again, be ready for an equivalent form. An equivalent form would be negative 4 on the top and x to the positive 3 on the bottom for the denominator. I should use the words numerator and denominator more, shouldn't I? All right, again, negative 2 gets multiplied down in front. Negative 2 times negative 7 is a positive 14. So this is going to be positive 14. X to the power of, well, negative 2 goes down to negative 3. So this is an answer. We'll box that. Oh, that was a weird box, wasn't it? Better. And this is the same thing as a 14 over x to the power of positive 3. Be ready for both forms. And in number 24, so to find f prime of x, I'm going to be multiplying this negative 2 down in front. And you can probably see what's about to happen in your head before even writing, I hope. This 2 and this 2 will cross cancel. This negative and this negative will cross cancel, leaving behind a kx to the power of negative 3. But let's go ahead and show all of our work. What we have before is a negative k over 2. And then we have x to the power of, it's going to go down to a negative 3. This negative 2 came down in front. So a negative 2 comes down in front. It's technically negative 2 over 1. And it's being multiplied by that negative k over 2. So I'm going to cross the negative, and I'll cross the 2. Maybe I can do that in a different color to make that really pop. The 2 and the 2 are gone. And that will leave behind a positive kx to the negative 3, which, again, that is a final answer, so you can box that. But it's the same as saying k divided by x to the power of positive 3. Be ready for that form. All right, number 25. So the first thing that I see is that I have a fraction, and until we hit lesson 2-10, you don't know how to take the derivative of fractions, also known as the quotient rule, so you need to unquotient this. I'm going to say, okay, I'm not going to take the derivative yet, so I'm going to rewrite the dx, the derivative with respect to x, and I'm going to say I'm really taking the derivative of 3x to the power of negative 2. You leave this behind when you're not taking the derivative yet. Now I'm going to take the derivative, which means I'm going to use up the derivative. I'm going to say this negative 2 is multiplied by a positive 3, making this a negative 6x to the power of, and I'm going to go down from negative 2 down to negative 3. So this is the answer, of course, but be ready for an equivalent form, which would be negative 6 stays on the top, and x goes to the power of positive 3 on the bottom. Again, in number 26, I'm not ready to take the derivative yet, so I'm going to say, okay, don't take the derivative yet. Don't use up the derivative with respect to x. I'm going to rewrite this as negative 6x to the power of negative 3. Now I can do this problem, and I can say this is equal to, the negative 3 is going to be multiplied down in front. A negative times a negative is a positive. 6 times 3 is 18. This is going to be a positive 18x to the power of. It goes down from negative 3 to negative 4. So this is an answer, box it, but be ready for an equivalent form. Be ready for an equivalent form, which is 18 stays on the top, and x goes down to the bottom for a positive 4. All right, and number 27, again, you need to rewrite this. You can say f of x, notice I'm not writing f prime of x, I'm just rewriting f of x, is really a times x to the power of negative 3. Now I'm ready to take the derivative. Now I'm going to do f prime of x. And you know what's going to happen. Negative 3 is being multiplied down in front. Negative 3 times a is negative 3a. X to the power of, it goes down from negative 3 to negative 4. So this is an answer. And its equivalent form would be negative 3a stays on the top. This x to the power of 4 is now in the denominator, and it's now a positive exponent. All right. In number 28, again, I'm not ready to take the derivative, so I'm going to say the derivative with respect to x. I'm not going to take the derivative yet until I unquotient this thing, make this a non-fraction. I'm going to say this is really negative 9x to the power of negative 4. Again, I didn't explain it very well in the last problem, but whenever you switch this switch sides, you just multiply the power by a -1, or you take the opposite of whatever the power is. So now I'm ready to take the derivative because I don't have any sort of fraction happening. This is going to be taking the derivative, and I'm going to say a -4 times -9 is a positive 36. So this is going to be equal to a positive 36. X to the power of, well, -4 goes down 1, it becomes -5. So this is the answer. But be ready for the equivalent form. The box was not quite large enough, was it? Aye, come on. There we go. This is the same thing as a 36 staying in the numerator and x to the power of positive 5 in the denominator. All right, number 29, again, we're not ready to take the derivative yet, so I'm going to keep the derivative with respect to x, and I'm going to say this is really 2x to the power of -5. Now I'm ready to take the derivative, and I'm going to say this thing is equal to -5 being multiplied down. -5 times 2 is a -10, x to the power of, and then this goes down from -5 to -6, and there's our answer. Thank you. All right, and from here, you can say the equivalent form is -10 in the numerator and x to the positive 6 in the denominator. Again, I've said this before, but I'll say it again. This negative can live in the top, it can live out in front, it can live in the bottom, but it can't be a mixture of the two. Technically, it can be a mixture of all three, which is the first time I'm really admitting that. This is also the answer, but it's kind of weird to say. It's not simplified. You want to get rid of as many negatives as possible. So this function is not ready to take the derivative, so I'm going to rewrite the function. F of x is the same thing as x to the power of -4. Now it's not a quotient, now it's not a fraction, and now I can take the derivative. Now I'm going to say f prime of x, and then the -4 is going to come down in front. There's nothing to multiply by, so I'm just going to rewrite the -4. X to the power of, this goes down from -4 down to -5. And there's our answer, which we're also going to find the equivalent form for. This is the same thing as -4 being left in the numerator, and x to the positive, oh, that was a terrible 5, x to the positive 5 in the denominator. All right. Number 31, oh, we got some radicals happening. I have a square root of an x. I'm not ready to take the derivative, so I'm going to rewrite the derivative, d dx, the derivative with respect to x. And I'm going to say this is really x to the power of 1/2. Why 1/2? Because it's a power of 1 up here, and the hidden index here is always supposed to be a 2, so it's this number divided by this number for this, what's the word I'm looking for? Fractional is not the word. This rational, there we go, this rational exponent. Now I'm ready to take the derivative, so I'm going to say that this 1/2 is going to come down in front. This is going to be 1/2, and then x is going to be to the power of. If I go down from a half, you have to be careful how to do this. I'm going to do some scratch work over here. If I have 1/2 and I need to subtract 1, that's the same thing as doing 1/2 minus 2/2. And whenever I have that, you leave the denominator. I can't speak. You leave the denominator. And I say 1 minus 2 is a -1, so -1. You can see, yes, it's going to go down to a power of -1/2. So I can say up here, -1/2. And that is the answer. I don't think the answer will ever look at. Like 0% of the chance will you look like that for a multiple choice question. So technically it is the answer. I can go ahead and box it, but you need to be ready for the equivalent form on this one more than any other question. This is the same thing as 1 over 2x to the positive 1/2. What did I do? This x used to be living on the top, and now it's living in the denominator, and now it's a positive 1/2 instead of a -1/2. But this is still probably not going to be the answer, because you should be familiar that the power of 1/2 means it's a square root. So this is really 1 over 2 square root of x. And that's the answer that you'll most likely see on multiple choice test. All right. So I think from here on out, anytime that you have a radical or a negative power, make sure you don't have a negative power, make sure you do have a radical in your final answer, just to practice. I know that this is mathematically correct, but that's not what you're going to be seeing on a test. So this is funny. In number 32, literally, there's a 2 here, so if I just slap on a 2 right here, that is the answer. So I can just copy that right over here, and then the 2's would cross cancel. It is going to be 1 over square root of x. Let's see if we can get that the long way. So before I take the derivative, I'm going to rewrite the derivative with respect to x. This is going to be 2 times x to the power of 1/2. I've gotten rid of the radical, and those are the 2 rules from the notes, right? You get rid of the radical, get rid of the fractions, and then you're ready to take the derivative. I've gotten rid of the radical, I'm ready to take the derivative. This is going to be, I have the 2 out in front. I'm going to multiply this 1/2 out here, 1/2, I'm going to rewrite it right here, 1/2 times 2, and this is x to the power of, and then we already know to go down 1 from 1/2, you go down to negative 1/2. So, of course, the 1/2 and the 2 are going to cross cancel, leaving behind, this is just going to be x to the power of negative 1/2. But again, this is the answer. Again, I could box that, but it's really weird to box that one because it feels like it's not simplified. So this is really 1 over x to the power of positive 1/2, which is really 1 over the square root of x. That's typically what you're going to be seeing. That x is weird. Typically what you'll be seeing on a multiple choice test. And I hope there's a student out there yelling at me, Mr. Sindel, you left a radical in the denominator. You're not allowed to do that. Okay, well, fine. I will go ahead and do some more steps. If you wanted to, like, this is purely optional and not ever needed in AP Calc. AB, at least. I'm not a master of BC. To get rid of rational, or not rational, what's the word? Radical denominator. Of radical in denominator. It's called rationalizing the denominator, right? No, just making it simplified. So if you did have this problem, 1 over the square root of x, how would you get rid of the square root in the denominator? Because typically in math, you're not ever allowed to have a square root in the bottom. They do it all the time in AP Calculus. They're okay with it. So how would you get rid of it? Okay, well, you would multiply this by the square root of x, like always. You say this is going to be equal to the square root of x in the numerator, and x squared being square rooted in the denominator, which is just the square root of x in the numerator divided by x. Ta-da, I've done it. There's yet another right answer, but you don't need to do that. Please, please never do this. I'm gonna write that in the notes. Please don't do this. It's just too much work, and it's not ever needed. Not ever needed. Anyway, just kind of a side tangent there. Let's continue on. I made the video too long, didn't I? I need to rewrite the function. This f of x needs to be rewritten without any radical. This is 3x to the power of 1/2. Now I'm ready to take the derivative. F prime of x, this is going to be 1/2 is being multiplied down in front, right? This 1/2 is right here, and I'm going to rewrite the rest of the problem, 3x, and now it's not positive 1/2. I'm going to subtract 1 to get negative 1/2, and that's the answer. I can box it if I want to, but I know what I'm going to do. I'm going to say this is really 3/2 x to the negative 1/2. This is a little bit more simplified. I would box this one more than the previous step, but it's not done. You should go further. This is the same thing as 3/2, and then I can put the x in the denominator, which means I need to actually leave some room here, and I'm going to put the 2 here, and it's going to be x to the power of positive 1/2, because again I switched this positive 1/2 or negative 1/2 to positive 1/2 by bringing this entire thing into the denominator. Now it's in the bottom, right? And now I can rewrite this as 3 over 2 square root of x. And that's what you're looking for on the AP test. We're getting close. Number 35. Or 34, sorry. Okay, so this one has 2 problems. First, I see a fraction, not okay. Second, I see a radical. There's 2 bad things with this thing. So the first thing I'm going to say, this is the same thing as the derivative with respect to x of 1 over x to the power of positive 1/2. So I got rid of the radical. Perfect. But now I have a fraction, so I need to do this again. I haven't taken the derivative yet. I'm still rewriting d dx over and over until I actually take the derivative. And this is the derivative with respect to x of x to the power of negative 1/2. Now that I've rewritten it in the correct form, now I can use up the derivative and write the problem. This is 1/2, negative 1/2 out in front. This power of negative 1/2 came out in front. There it is. And I'm going to rewrite x to the power of, now I'm going down a power again. If you are not okay with fractions, let me do some scratch work for you. I had negative 1/2. I need to go down 1, which is the same thing as saying negative 1/2 minus 2/2, and keep the denominator the same now that we have like denominators. Negative 1 minus another 2 is a negative 3, and our answer up here, this is a negative 3/2 power. And then there's the answer, right? But again, you'll never see that on the AP test because they love making sure you know how to rewrite all this negative stuff. So what that means is I can rewrite an equivalent form. I can say this is really let's put the negative out front so I don't forget. Negative 1 over 2 x to the power of positive 3 halves. And then from here, this is going to be negative 1 all over 2x cubed that's being square rooted. And there is an equivalent form. So as a minor note, I know that you guys have mastered Algebra 2, but let me remind you, this 3 can live inside the radical or it can live outside the radical. It doesn't matter. Let me show you another equivalent form. This is negative 1 over 2 square root of x to the power of 3. These are all equivalent forms. These are the most two likely to show up on an AP test. Usually they like putting it inside the radical, but it doesn't really matter. They're the same form, right? Number 35, I've gone on enough tangents to not do this. Okay, so I can't take the derivative yet until I rewrite the form. This is going to be the same thing as a negative 2 over x to the power of 1/2. That 1/2 can be spaced out a little bit better. And again, it's a fraction, so I need to not take the derivative yet, keep rewriting the ddx. And this is going to be negative 2x to the power of negative 1/2. And now I can take the derivative. That derivative, the negative 1/2 is going to be multiplied by the negative 2, and the negatives will cross cancel. 1/2 and 2 will cross cancel, leaving behind the x, and it'll go down to negative 3/2 again. But I want to show all my work, so I'm going to rewrite the negative 2x. So here it goes. This negative 1/2 is going to come down in front, and I'm going to say this is negative 1/2 being multiplied by the negative 2, and this x is going to be the power of negative 3/2 because I went down 1. And things will cross cancel. The negatives are gone. The 2's are gone. And then from here, what's left over is this x to the power of negative 3/2. This is, again, you can say it's the final answer, but most likely it's going to be in an equivalent form, which is going to be 1 over x to the power of positive 3/2, which is the same thing as 1 over the square root of x cubed. And I have said it before, and I'll say it again this time. Be wary that it could potentially have that cubed on the outside. I'm going to go ahead and write it. It's 1 over the square root of x to the power of 3. That 3 could have been rewritten better. 3, that is also another equivalent form. All right, number 36. Oh boy, we got to rewrite this thing. So f of x is equal to, so first I'm going to say it's 2 over 3 and then x to the power of 1/2 instead of a square root of x. And it's still a fraction, so I'm going to leave, unfortunately, the 2 over 3 is going to have to stay there. 2 over 3 is going to stay there, but then I'm going to have x to the power of negative 1/2. And you might be asking, but Mr. Sindel, you said don't take the derivative of fractions. If they're just numbers, they're okay. But if I have x in the denominator, that's never, ever okay. So I got the x out of the denominator. I'm ready to take the derivative. So now I'm going to do f prime of x, indicating I am taking the derivative. And I'm going to take the derivative. This negative 1/2 is going to live down in front. Negative 1/2 is being multiplied by a 2/3, which is multiplied then by an x. If I go down 1 from 1/2, or down 1 from negative 1/2, I go down to negative 3/2. And that's the answer, but let's go ahead and simplify it a little bit. The 2's are going to be gone, and this is really the same thing as saying negative, I'm going to put that x back on the top. I'm going to say negative x to the power of negative 3/2 all over 3. That is an answer. I guess it's complicated enough that it might show up on a multiple choice test, but be ready for the equivalent form, which looks like this. This is the same thing as saying there needs to be some sort of negative, so let's just leave negative placeholder on the top. And this is really 3x to the power of positive 3/2. Now that we switch it to the denominator, we need something on the top, so you leave the 1. And then from here, I can say this is the same thing as negative 1 over 3 to the power of, or 3 times, let's say, the square root of x to the power of 3. I didn't give enough room in there, did I? Let's go ahead and write the x a little bit smaller. X to the power of 3. Man, my 3's today. There we go. That is an equivalent form, but be ready for yet another one. This is the same thing as negative 1 over 3 times the square root of x, and then power of 3 on the outside. All of those are equivalent forms. Look how many answers are being boxed here. Crazy. All right, last 3 questions. We're almost there. Okay, so these rules we didn't quite talk about, but it is here. It's called the addition rule. Essentially, you have the derivative and you distribute it. So if you take the if you take the derivative of ax to the power of n, take the derivative of ax to the power of n. If you're taking the derivative of this thing, you're taking the derivative of this thing. It works. It's essentially distributing the derivative. That's the best way to explain it that I know of. So let's go ahead and do that. I'm going to, in the notes, say I'm going to take this derivative and I'm going to apply it to all 4 of these things. So if I take the derivative of 5x to the power of 4, 4 gets multiplied down by the 5, and this is going to be 20x goes down to a power of 3. Minus, okay, 2 multiplies down in front. 2 times 3 is 6. This is going to be 6x to the power of, it goes down from 2 to 1. So I can write down a 1, but you don't write down a 1 if it's simplified, right? Plus, okay, how do I take the derivative of a linear function? The derivative of 2x is just 2. The rationale for that, in case I forgot to mention in the notes, is power of 1. It goes 1 gets multiplied down in front, so it's still 2, and then 1 turns into a 0, and anything to the power of 0 is gone, leaving behind just the 2. And then plus, and then the derivative of 6 is 0. Whew. All right, so my final answer is 20x to the power of 3 minus 6x plus 2. There's the answer we're looking for. Number 38, second to last problem. Again, distribute the derivative. It's going to go here and it's going to go here. But I can't do that yet because this is an x in the denominator. It's a fraction. I don't want to use quotient rule. I need to rewrite this. So this is really, I'm going to say it's the derivative with respect to x of x to the power of 3 plus, and this is going to be 7 times x to the power of negative 2. Now I'm ready to take the derivative. So when I take the derivative, I have 3x squared. Again, 3 comes down in front and it goes down to a power of 2. Plus, it's not going to be a plus in this case. Can you see why? The negative 2 is going to multiply by the 7. That's going to make a negative 14. Negative 14 x to the power of, I'm going to go down from negative 2 to a negative 3. And that is technically the answer. So I should be writing that these are all equivalent statements. There are equal to signs in between them. I want to make a slightly larger rectangle. And in case you need its equivalent form, this is going to be the same thing as 3x squared minus 14, which stays on top, and x to the power of positive 3 in the denominator. Excellent. Last problem on the homework. We're almost there, boys, girls, everyone. So, am I ready to take the derivative? There's no fractions, there's no radicals. I'm ready to go. Let's go ahead and take the derivative. I'm essentially distributing the derivative. F prime of x is going to be equal to, all right, here we go. Negative 3 multiplied down in front is going to be a negative 9x to the power of. It goes down from negative 3 to negative 4. Okay, next, I have a negative 2 times another negative 2, which is a positive 4x to the power of. It goes down from negative 2 to a negative 3. Okay, next I have 4 being multiplied down in front. It's going to be a plus 4x to the power of. It goes down from 4 to 3. Plus, and then what do I have here? 7 multiplies down into 16, which is going to be 112. And I'm going to get 112x to the power of. It goes down from 7 to 6. And, technically that is the answer, but just in case they're trying to rewrite those negative powers on us, it is also the same thing as a negative 9 being left in the top, x to the power of 4 in the denominator, plus 4 in the top, all over x to the power of positive 3, plus 4x to the power of 3, plus 112x to the power of 6. And there's our final answer, which we'll then box. Another equivalent form. And that, ladies and gentlemen, concludes Worksheet 2-1, Basic Power Derivatives for AP Calculus AB. There's the back. There's the front. Thanks for watching.